Hi, my name is Jia Zhang. My topic here is the computer algorithm design. With this topic, I want to learn a new form of architecture and a new way to create architecture, and what will it look like and where it will go in the future. Firstly, I want to briefly introduce the timeline of computer graphic history. So in 1951, we had the first computer with a video display of a real-time data. And in 1971, we had the first video game, The Space War. And in 1977, we had the Apple II, which is the first graphic personal computer. And in 1995, we had the Toy Story, the first fully CGI movie. And now, what's the computer graphic technology looks like? So I have a video. So with this video, I found that today's we have a big development of the computer graphic technology, and I find one is named Vinyl, and I have a study case here to learn how to use Rhino to build up different interesting form. So the first case, this group of students, they want to use the computer software Rhino to explore different structure of bricks. So firstly, they are not use hands to build the model. Instead, they use the computer software to explore so many structure, and finally they find one they want to build, and then they come back using hands to build the physical model, and then they build the final brick model in the real world. With this project, they find that they use computer software. It helps them to save time and explore more possibility to build structure they want. And for the second case, this is the New York vessel. The architect with this project, he want to reduce the beams and column. He want to use the geometry to build the whole building. And I have a video for this study case.
You're working on Vessel, which is part of a $1 billion Hudson Yards development. What's the value of a structure like that in such a commercial area?
The whole project is made from an assembly of infrastructure. It's made from pieces of staircases and landings. But of course, it's the way in which they're arranged together that makes something that holds people and invites people to move around it, meet, dwell, eat a sandwich, take a photograph, read a book, but is almost like a new piece of three-dimensional public space that's lifting the public off the ground. And the idea behind that is very simple. It's to have a small footprint on the ground, to not use up the valuable public space. But then as the project grows and moves up, it gets wider, it gets bigger, it has more capacity. And so many, many people can enjoy it and use it.
So how tall is Vessel going to be?
Its total height above its footprint is 150 feet, and it's almost exactly the same dimension at the top of its crown, which is 150 feet. We really saw our challenge as being a piece of strategy as opposed to a piece of art that is passive, that people look at, applaud, take a photograph of, but then fundamentally forget. We really tasked ourselves with coming up with something that felt phenomenal, unique, sort of magnetic in its presence, but actually fundamentally useful.
And so for the third study case, this is the water cube in Beijing, China. So the architect want to explore a new form of shape of geometry instead of the rectangle or triangle. So they use computer software, and finally they find a new type of geometry, and they named it the smart geometry, and they use it to build the whole facade of the building here. So for my own project, I want to rebuild the building named K1299. The reason I want to rebuild it because this project uses Rhino also, and I want to with this process to really understand how it works and the logic behind this project. So I try to rebuild it. And here is my work here. And you can see firstly, I built a plane here with the X and Y number, and then I divide this whole plane into a grid. And then I build 3 points here. This 3 point is where I want to hit the facade and push this area backward. And finally, I have the facade as the project looks like. And then I bake it and make the final version of my project here. And with this process, I have a better understanding about Grasshopper and Rhino, and I found how they works with this building. And I hope after I learn this technique, I can use it in my future architecture projects, and I hope it can help me to explore more different type of structure and different type of facade. And this is all I have for today's. So thank you.